that I do for you. So, so if you've got questions, I got the chat box open. You can also unmute and ask. We'll start with that. We can all pull up the practice exam. I still don't know why that's so hard for me to say, but I will pull that up and, look at specific problems from there.
Are we supposed to be turning in work for the practice exam?
No, not for the practice.
Just for the next exam, right?
Yes.
Okay, cool. Thanks.
Mm-hmm.
Is the practice exam also for a quiz grade like last time?
Yes, it is. And see, it is hard to say. It's not just me. Maybe we should start calling it practice test. That's easier to say. Anyway, yes, it is for a quiz grade. It's just like last time. You can take it as many times as you want and get 100, but yeah, so it'll be for a quiz grade and you'll have to turn it in by Sunday.
And then do we
go ahead.
start the next chapter on Monday?
Yes, we're going to start 13 on Monday.
Okay, cool. I don't have any questions over the exam or any homework, so.
Okay. Yeah, even if you don't have questions, it's always, it's always good to come in and see if anybody else does. Which I know, like in my first class, I had quite a few people there, but not many people actually had questions. They just kind of listened to other people's questions, and that's fine. But yeah, anything that comes up, in your minds that was tough or you just, aren't sure how to solve, we can look at those. And honestly, you guys, the stuff that's on the practice test, it's all homework stuff that you've probably seen, other than 12.5, which, is our newer stuff. If you've done the homework already for that, you're not seeing any questions that are a surprise. You've worked them all at some point.
I have a few questions about the last problems on the practice exam.
Okay. Ooh, you said it really well. Yeah, so let's so the last questions, I'm guessing the related rates ones.
Yeah, just like the word problems I always have trouble with. So
Okay. All right. And then from 12.5, problem 3, so that's also a related rates problem. So let's look at the exam ones and then look at 12.5 number 3. Let me share. So you should see my, it should say practice exam 2. And let's go to the end. So I think it's the last 3 that are word problems.
I think so.
Yeah, so I think this was the first one. Let me go back. I'll go back one just to, nope, that was one too. Okay, but that's not one. Okay. Yeah, 3, 16, 17, 8. No, how many? Oh, there's just 18. Okay. All right, guys, so let's look at number 16. So on the word problems, one way to know that this is related rates is because the only word problems I give you in this exam are related rates. But otherwise, guys, you're looking for words like rate. If it says rate anywhere, you know that that's what we're going to do. I just figured out that you can change the color of the pen you write with here in Zoom, so I've been having some fun. They don't have tons of colors, but I like this. Ooh, let's do pink. Let's do pink. Okay. All right, so I see the word rate, and I'm like, all right, definitely a related rates problem. Also, again, rate of change and respect to time right there. That's a good indicator. So what you're going to do is you're always going to take the equation that they give you. So 9, and the numbers change a little bit on these, but the basic template is the same. So you're going to differentiate with respect to time. So you're always going to take the derivative of everything with respect to time, and that's going to be a first step. So you guys, let's go ahead and do that, and then we'll talk about what it's giving us and how to put that in. So 3r squared, we take the derivative of that, and we get 6r. But don't forget, everything gets a dt. So it's going to be 6r dr dt. And then over here, bringing the 3, oh, gotta get calculator out. See what 3 times 957 is. So 3 times 957. So we get 2871 n squared, but that also gets a dt. So dn dt. And so usually the derivative isn't too hard as long as you remember everything gets that dt term. Now it's what to put in. So we are looking for dr dt. Notice it says find the rate of change of revenue with respect to time. So we do not know dr dt. So I can't put anything for that, but I should have a value to put in for actual r and a value for n and dn dt. I just have to find them, and I have to know how to write them. So let's notice up here, it says that in 2012, so you don't really have to worry about the year there. It's just telling you at some point in time. Your revenue was 36 billion. And no, this is like the one we did in class where the revenue is in millions. So you're going to have to be careful. 36 billion, we can write that as 36,000 millions. That's what we did, right? It's not, it's 1,000, right? I think so. Guys, I don't know why. It always gives me trouble going from billions to millions, or like, you know, when you're in those big numbers. But I think it's 36,000 million. So we're going to use 36,000 for your revenue because it's in millions. And then it says we had 184,000 employees. So notice that N is number of employees, but be careful on the units of this one too, because it says N is in thousands. So you're not going to write 184,000, you'll just write 184. And then what else do we know? We know that we were adding employees at this rate of 12,000 per year. You guys, this is DNDT, how the number of employees is changing over time. Because it is adding, it'll be a positive, and it's in thousands, just like N is, so it'll just be positive 12. So we already took the derivative of everything with respect to time. So now we want to put all this information in. So you never put any of this stuff in until you've taken the derivative, but now we have. So we have 6 times your R of 36,000. We don't know DRDT. Equals 2871 times your N of 184 squared times DNDT, which is 12. So let's start by doing the math on each side separately. So let's do 36,000 times 6 and get 21,600 DRDT equals, over here, make sure you do the 184 squared first. So I got that number. Now I'm going to multiply that number by 2871. And then I'm going to multiply it by 12 and get 1,166,406,912. So I get a very large number in the billions. And then I'm going to divide both sides by 21,600. You guys, I'm missing a 0. So guys, I've said the number 36,000 multiple times, and every time what have I written? 3,600. Guys, I was saying the right number. I know I said 36,000, but I was writing 3,600. That's a problem. And I don't know why I did that, guys, but I'm missing a 0 here because my answer was a 0 too little. Or actually a 0 too big. But guys, so I don't want to confuse you. R is 36,000, like I said, but for some reason I wasn't writing 36,000. I was writing 3,600. So I don't know if you were doing that too, following along, or just listening to my words, which were actually correct. But guys, R is 36,000. I know how to write thousands. So you guys, what's going to happen to our thing? It's going to change a little bit. So the 36,000 will be here. This 21,600 will have another 0. So it'll actually be 216,000. So add a 0 to that term we're dividing by. So yeah, I left off a 0. I'm not really sure why. Just a brain thing, I guess. So now I'm going to have to divide again. So I have 11,66,406,912. Now I'm going to divide by 216,000. There we go. So you guys, I get DRDT is 5,400.032. So you guys, one part that's a little bit harder about this question is how to write your answer. So remember, R and DRDT, they are the revenue, which is in millions. So 5,400 millions is what we get. So it also, note over here, it wants you to round to the nearest billion. So you guys, this is 5,400,000,000. What would be the nearest billion here? It would just be 5, right? So I'm going to round down to the nearest billion and get about 5. And your answer would just be 5. I think the easiest way to go on this one is, so like say you got 4,732 point something. If this is your answer, for example, remembering that this is in millions, you're just going to round the first number, right? The 4 and then the 7, you're going to round that up to 5 billion. If you had 3,243 as your answer, what's that going to round to? Well, you're going to round it down to 3 billion. So be careful on this one. They really do just want a single number. So you're going to round to the nearest billion. And don't do what I did and say 1,000 and write 100, because that will definitely throw you off, obviously. But yeah, so take the derivative of everything with respect to time, then put in your correct values and solve for the missing rate. So let's look at the next one. Move this a little bit. So on number 17, we are given a formula for the volume of a cantaloupe. Right here. So we have V equals 4/3 pi r cubed. And you guys, let's see what we know. So I know that the radius is growing at a rate of 0.5 centimeters per week. So radius is always r. And I know how the radius is growing, or I know how it's changing over time. So that tells me about DRDT, and it is growing, it's getting bigger, so it's going to be a positive 0.5. And it tells me that this is at a time when the radius is 7.4, so it's also giving me R. It doesn't give me any information about volume other than to say that's what I'm looking for. I want to know how the volume is changing, so that tells me I'm looking for dV dt. So here's what I know, here's what I'm looking for, and then I'm going to do the same steps as I did last time. I'm going to take the derivative of the whole equation with respect to time. So you guys, the derivative of V with respect to time is just dV dt, because it's just a V by itself. So we'll get just this by itself, because everything gets that dt. Now, just be careful here. Remember 4/3 pi, all of that is just a constant number. So when I bring the 3 down and multiply by 4/3, The 3's actually cancel out. We'll be left with 4 pi, and then we'll have r squared, but don't forget, everything gets a dt. So it'll be dr dt. Then I've taken this derivative with respect to time. Now I can put in my r and my dr dt that I know and get dv dt equals 4 pi times 7.4 squared times dr dt, which is 0.5. So on this one, it wants you to just put all this in a calculator and then round it to 1 decimal place. Just make sure, and I think I mentioned it in class because we did one like this too. Things to remember when you're doing this: square the 7.4 before you do anything else. When you multiply it by the 4 and the pi, make sure you do use the pi button and not just 3.14. But then when you multiply all this together, you should get, you get 344.06, and then we round it to the nearest tenth, so you get that 344.1. So you guys, just being careful with your decimals. That's why, don't just use this as pi. Some people are just in that habit, and maybe that's not you guys, but I want to mention it because it's happened, and it'll make your decimals off, and it'll count it wrong. So be careful there. So again, just like the last one we did, we took the derivative of everything with respect to time. We put in what we knew from up here, and we solved. So the very last one, it's about t-shirts. So we did one very similar to this one. So you guys, it gives you the relationship equation. So I know that's what I'm going to be taking the derivative of with respect to time. What else does it give? You guys, on this one, it's the one where you have to know what it means by demand. So X is how many t-shirts they sell. You guys, your demand is that value. They're selling as much as are demanded. So it's telling you that right now they're selling 500 t-shirts. But notice this demand is dropping. So how is X changing? How is the number that they're selling changing? Well, that's going to be dx dt. And because it's dropping by 100 t-shirts a day, oh, hold on. Well, we'll talk about it in a minute. Here, why don't I do this? 500 t-shirts. We're dropping by 100, so that's a minus 100 t-shirts. But you guys, we need to note that X is in hundreds. So that'll get you on this one too if you're not careful. X is in hundreds, so X is 500 t-shirts, but the way I'm going to write that in my equation is just 5. And then dx dt, we're dropping by 100, so in hundreds, that's just going to be -1. So that's what I know. Do I know anything else? No, I don't know anything else, guys. So I can go ahead and start differentiating. So let me write this out here. So I have P equals -42x squared plus 583x minus 521. Let's take the derivative of everything with respect to time. So you guys, this is just a P by itself. The derivative of P with respect to time is exactly that, dp dt. This term, bring the 2 down, multiply it by -42, get -84x. Don't forget though, everything gets a dt, so you're going to have a dx dt there. This is just going to be plus 583, but again, dx dt, and then this term goes away. So from here, I can plug in what you know. So we don't know dp dt. But I do know x, so I'm going to have -84 times 5, and then times dx dt, which is -1, plus 583 times dx dt again, which is still -1. And then I'm going to stick that all in my calculator carefully. And let's see, so I get negative 84 times 5 times negative 1, that's just going to make it positive. So I get 420. This just is going to make this minus 583. So 420 minus 583. So I get for dp/dt negative 163. Remember, it's okay for these to be negative. It just means that the rate is dropping. And it would make sense. We're selling less t-shirts, so we're making less money. Okay, so let's go over to the homework in 12.5 and look at problem 3. Let's see. Here, let me stop share because I'm only sharing that specific screen with you. I'll pull it up and then I'll share with you again. So I'm going to close that. 12.5. Three. All right, so I'm going to share this with you now that I have it pulled up. So this is a problem from your homework, guys. Looks like this on number 3. Again, your numbers might be a little bit different, but it should look about the same. Okay, so, hey. Oh, I like to do this. Okay. Anyway, so you guys, I'm looking for dy dt. I know that x is 3, and I know that dx dt is negative 4, and then I'm given this equation. So notice that it gives me what x is, but it doesn't give me what y is. Jack, what are you doing? Okay. Sorry, there's just loud crinkling of plastic behind me. It'll stop soon. Okay, so anyway, we're here. You guys, I am going to have to take this equation and differentiate everything with respect to time. So, you know the drill. Everything's going to get a dt. But at a point, I'm going to need a value for y, and they only give me a value for x. So, and I'm going to need the x too. But you guys, I need to find out what y is in this situation. So how could I find that, you think? Well, if I have an x value, whoa, hold on. My hand touched the screen in a way that it did not like. Give me a second. Okay, so you guys, if I have x, and I do have an equation that relates the two of those things, then I can find y. So let's put that x equals 3 into our original equation. So you put it in, so like if you have x and you have to find y, or vice versa, find that before you do any derivatives. So you guys, I just put it in like this. You guys, 3 to the 4th is 81 plus y to the 4th is 337 minus 81 minus 81. So I get y to the 4th equals, let's see, what's 337 minus 81? 256. Oh, perfect. So you guys, then I'm going to 4th root both sides here. So over here, I'm just going to have y. Here, I'm going to have, was that 4? I think the 4th root of 256 is 4. I can confirm. Yeah, 4. Now, you might wonder, well, we did take a 4th root, so you might wonder about a plus or minus situation. And I actually wondered that too as I started working these problems, because it never explicitly says that we have to work with positive numbers or anything like that. But everything that I've seen, and as they work these problems and looking at answers they get, you guys, we're just using the positive root. And the best reason I know how to explain that to you is that x and y are both functions. And usually when we're looking at a function, we don't consider positive or negative roots because it makes things not functions. So think about it, guys. If these are functions, then when you put a number in for x, you should only get one value out for y, right? because that's what a function means. So that's why you only consider the positive root. And I don't even know if that was a thought that, you wondered about, but if you wonder about it, it's only the positive root that we're taking. So now I know that y equals 4. Now I'm going to take the x to the 4th plus y to the 4th equals 337, and I'm going to take the derivative of everything with respect to time. So I'm going to get 4x cubed dx dt plus 4y cubed dy dt equals 0. And then I'm going to plug in what I do know. So I know that x is 3, so I'm going to get 4 times 3 cubed. Do I know dx dt? Yes, I do. Dx dt is -4. Then I have plus 4. I just found that y is 4 cubed, but I do not know dy dt. So I'm going to have 4 times 27 times -4 here, and we'll work that in a minute. Here I'm going to have plus 4 times 64 dy dt equals 0. So you guys, let's go ahead and see what 4 times -27, or 4 times 27 times -4 is. This is going to be -432 plus, well, 4 times 64 is 256. So plus 256 dy dt equals 0. Let's add the 432 to both sides. We are trying to isolate dy dt, so we get 256 dy dt equals 432. And then to get dy dt by itself, we just need to divide both sides by 256. 6. So 432 divided by 256. It says to round to 2 decimal places, so what I got was 1.6875, but I'll go ahead and round that to 1.69. So yeah, on that one, as you're working it, no matter what yours looks like, it'll look very similar. It's going to give you the value for either x or y, and you need to find the other one before you start, really before you start doing anything else. And then when you when you are finding that, if you have even powers here, yours might not even have even powers, but if they do and you have to take an even root, just make sure you only consider the positive. Don't worry about plus or minus if it comes up. So anything else, guys? What else you got for me? If you want, so I did quite a few problems in my 10 o'clock class, and if you want, I can post that also to D2L. So I could post both 10 and 11 videos today. I'm going to do that for them. So, you know, that's a bigger pool of questions that I've worked today in class. So you can always look over there and see which ones I did, and they can look and see which ones we did. So some reminders. The practice exam is for a quiz grade. You can take as many times as you want. I do not need work turned in on a practice exam. That is due on Sunday night with 12.5. Your actual exam will be opening right after this class. So I'm going to open it as soon as we're done here. So you can take it anywhere from now until Monday night. So you do have till Monday night to take that. And then don't forget to turn in your work. So remember, I'm going to be very strict about that this time. I was pretty strict about it last time. There are a couple of people who didn't really understand, so I worked with them and stuff like that. But everybody's on the same page now. So everybody turns in their work to D2L, and that when I open the exam, I'll open that assignment too, to where you can see it. But that's all due on Monday night. And on Monday, we're going to be moving on to chapter 13. So don't expect it to be totally different. We're just going to be moving on to new things, but you'll still be able to work on your test that day.
Sounds good. Thank you so much for doing this.
All right, no problem. You guys, I want you to be really prepared. So, this should do it for you. All right, so I will let you guys go. If you do have any questions, you can email me, but just make sure you either screenshot the question you're working on from the practice or the homework, or something like that. Because if you ask a question and I'm not really sure if you're taking the exam or not, I'm probably not going to answer it. But yeah, so other than that, I will probably just see you guys here on Monday.
Hey, Sarah, thanks for leaving the exam open for so long. My week is crazy this week, and that really, really helps me out. So I just wanted to tell you how much I appreciate it.
Oh, well, thank you for that. I am glad. I feel like what's today? Today's Friday. So, I mean, you get half of Friday, Saturday, Sunday, Monday. I think that's pretty reasonable. So yeah, it's no big deal. And I will see you guys on Monday.
Sounds good. Have a good day.
You too.